Good day to all of you, or good evening. It is time for another virtual video lesson. I know you are super thrilled to hear my voice in your ears all the time. Anyhow, today we are going to talk about equations of lines, and then we're also going to start talking about midpoint and distance formulas. So if we recall from Algebra 1, I know that was many moons ago, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. Remember that we write the y-intercept as an ordered pair. Okay. And then point-slope form is y minus y1 equals m times x minus x1. Again, the slope is m, and then x1, y1 is a point on the line. Okay, and remember that in order to go to slope-intercept form, we start with point-slope form first. So that says start here. So again, we want to start with point-slope form and then go to slope-intercept form. The one time you can use slope-intercept form only is when you have a horizontal line, which is technically also standard form, or if you're given the y-intercept to start, which means you were given the x value to be 0. But if you were not given that, then you need to use point-slope form. So in order to start this problem, we need to find the slope. So y2 minus y1 over x2 minus x1. So that's 3 over 1, which is 3. Now remember, to go to point-slope form, it doesn't matter which point you choose. It does not matter. I'm just going to choose this first point. So y minus 5, make sure that you plug in the y in for y1 equals 3 times x minus 1. You leave your answer like this. So you leave those parentheses in there. Okay, if there was double negatives, then you would simplify the double negatives. But otherwise, leave the parentheses. Okay, so the next example says, write the equation in slope-intercept form. So that's y equals mx plus b, okay, of the given table. So first we need to find the slope. So I'm going to go ahead over here. And the change in y each time is 1/2, a positive 1/2. And the change in x each time is a positive 2. So to find the slope, we do the change in y over the change in x. So that's going to be 1/2 divided by 2. Remember that when you divide fractions, you multiply by the reciprocals. So 1/2 times 1/2 is 1/4. So that is my slope. Okay. I was not given the y-intercept. How do I know I was not given the y-intercept? Because none of the x values are 0. So that means I need to start in point-slope form. So y, and it doesn't matter which point we pick. I'm going to pick this one so I don't have to deal with any fractions. Well, for the time being. So y minus 1 equals 1/4 x minus 1. Okay. Let's distribute that 1/4 through. So y minus 1 equals 1/4 x minus 1/4. And then in order to be in slope-intercept form, I have to get y by itself. So I'm going to go ahead and add 1 to both sides. So y equals 1/4 x plus 3/4. How did I get that? Well, think of a dollar. There's 4 quarters in a dollar. So if I have 1/4.
Attention.
Sorry about that. They just came over the intercom about the buses leaving. But anyways, with a dollar, if you have a negative 25 cents and then you add a full dollar, that's going to give you a positive 75 cents, which is 3/4. Okay. All right. The next problem asks us to find the slope, the y-intercept, and the x-intercept of the following line. So to find the x-intercept, we plug in 0 for y. So 3x plus 7 times 0 equals negative 10. So 3x equals negative 10. X equals negative 10 over 3. Now, when you write your x-intercept, you should always write it as an ordered pair. So my answer is negative 10 over 3, comma 0. For the y-intercept, technically you could solve for y to find this, but algebraically, we plug in 0 for x. So we get 7y to equal negative 10. So y equals negative 10 over 7. So 0, negative 10 over 7. Okay. And then finally, and I'm starting to run out of room here, we need to put it in slope-intercept form, which means you need to solve for y. So I'm going to zoom in. And so I'm going to subtract 3x from both sides. So 7y equals negative 3x minus 10. Divide everything by 7, so y equals negative 3 over 7x minus 10 over 7. And notice that this is the same as the y-intercept we found earlier. So we did it correctly. Okay, the next two problems before we go on to distance and midpoint formulas. The next two have to, you're given an equation of a line and you have to write another one. So I want an equation of a line that passes through 2, 3, okay, in point slope form and is perpendicular to this line. So remember that perpendicular is opposite reciprocals. Okay. So in order to find the slope of the given line, I need to put it in slope-intercept form. So I'm going to subtract 2x from both sides. So I get y to equal negative 2x plus 4. So the slope of this line is negative 2. But I want the opposite reciprocal, which means I need to do the opposite sign and flip it. So m equals 1/2. That's going to be my equation of the new line that passes through, 2, 3. So put it in slope form, y minus 3 equals 1/2 x minus 2, and you are done. So again, you need to find the slope of the given line first, which was negative 2, but then you wanted opposite reciprocals, so it's perpendicular, and then just plug in the point for point slope form. And then same thing for the next one, but we're going to write it in slope-intercept form, and it's going to be parallel. So still have to find the slope of the given line, so subtract 3x. So negative 4y equals negative 3x plus 2. Divide by negative 4. So y equals 3/4 x minus 1/2. So I want the slope of this line, so 3/4. And since it's parallel, we use the same slope. Then from here, if we want to go to slope-intercept form, we have to start with point slope first. So y minus 5 equals 3/4 x minus a negative 8. So we have y minus 5 equals 3/4 x plus 8. That would be considered the simplified version of point slope form. And then y minus 5 equals 3/4 x plus 24 over 4, which is 6. And then finally, solve for y, so y equals 3/4 x plus 11. Okay. So same exact steps as previous problem, but this time instead, the lines were parallel, so we use the same slope. All right, we're going to skip some of this. Since we've already talked about the midpoint formula of lines, let's just go ahead and write that down. So the midpoint formula is x1 plus y1 over 2 and x2 plus y2 over 2. So remember that since it's the average, you add them together. You find the middle. So if I'm starting from 0 to 10, the middle would be 5. 0 plus 10 divided by 2 is 5. Okay, so let's just go ahead and do this practice problem. So 5 plus 2 over 2 and 12 plus -4 divided by 2. And by the way, real quick, it says find the midpoint of AB. So that means you were given the end points of the segment. So since you're finding the midpoints, you're given the end points. Okay. So that just equals 7 over 2 and 4. Okay. In the next example, it says M is the midpoint of ST. So that means that this right here is the midpoint. So you were not given the endpoints, you were only given one. So that means you're missing an X and you're missing a Y. So if we focus on just the X's, okay, we would do 1 plus X divided by 2 equals -3. Where did I get all the information from? Here's one endpoint. I'm missing another endpoint, so that's where the X comes from. Divide by 2 equals the midpoint value. Okay. And then from here we just solve. So we multiply by 2. So 1 plus X equals -6. So X equals -7. Okay. And then we do that again with the Y's. So 6 plus Y, because I'm missing a Y, equals 3. Because that is the Y value of the midpoint. Times it by 2. 6 plus Y equals 6. So Y equals 0. So my end point, my other end point is -7, 0. And at the end of the problem, you can check your work to make sure that if you use these two endpoints, that you will get the midpoint. Okay, so that's the most important thing about the midpoint. For the distance formula, okay, we can actually use the Pythagorean theorem to find the distance. Okay, but we're going to kind of just skip that, but just make that connection there for me that the Pythagorean theorem is a squared plus b squared equals c squared. And you're going to find some similarities when we go to do the distance formula that it sounds a lot alike. Okay, so let's go ahead and go to the next page. And we'll do one Pythagorean theorem problem, just one. Okay. So first we need to find the distance between each point. So basically what we're doing is we're creating a triangle. That's when you use the Pythagorean theorem, is for a triangle. So we need to find the distance between these two x values. Well, if I'm starting at -2 and I'm going to 4, that is a space of 6. So algebraically, that would be 4 minus a -2, which is 6. Okay. And then same thing for the y's. If we have -5 here and we have 3 here, that's 3 minus a -5, which is 8. So now let's go ahead and use the Pythagorean theorem, which is a squared plus b squared equals c squared. So 36 plus 64 equals c squared. So 100 equals c squared, so c equals 10. Okay. So the distance formula is derived from the Pythagorean theorem, because distance is squared is x1 minus x2 squared plus y1 minus y2 squared. Okay, so notice how it is similar. A squared, b squared equals c squared. Okay, but if we want to get the distance alone, then I need to take the square root of both sides. So the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay. Again, technically, you can flip the order of this and do x2 minus x1. Just make sure you do the same thing over here and do y2 minus y1. All right, so we have 2 problems left. So the first problem is to just find the distance. So we're given 2 points, the endpoints. So find the distance. So distance equals the square root of 8 minus a negative 2 squared plus negative 1 minus a negative 4 squared. Again, I could have done negative 2 minus 8 and negative 4 minus a negative 1. Just make sure that you keep it in order. So if you start with the first x here, then make sure you start with the first x here as well, and the first y, okay? So distance equals, that's going to be 10 squared plus 3 squared. Okay. When you are done squaring these, you should get 2 positive numbers to add together. So 100 plus 9, that gives me the square root of 109. 109 cannot break down into anything, so you are done with the problem. All right, last problem. It says, find the center and radius of the circle that has a diameter with the following endpoints. So if you are given the diameter of a circle, then that means the center is going to be the midpoint. Think about why. Because the center is on the middle of the diameter. So that would make sense that it's the midpoint. So midpoint equals, we add these together because we're taking the average. So the midpoint is negative 1/2 and 10. So that is the center of our circle. Now to find the radius, there's 1 of 2 ways you can do this problem. You can either use an endpoint and the center to find the distance of the radius, or you can find the radius or the distance of the diameter and then divide by 2 to find the radius. The reason why I'm going to pick that route is so that I don't have to deal with squaring a fraction. So the distance for the diameter is the square root of 2 minus the negative 3 squared plus 4 minus 16 squared. So that gives me 5 squared plus negative 12 squared. Remember that when you square a negative number, it becomes positive. So 25 plus 144 equals 169. Then we need to take the square root of that, which is going to be 13. So that is the length of the diameter. Okay. But the question asked me for the radius. So for the radius, I need to take that diameter and divide by 2, because remember that the radius is half the diameter. Okay. So again, you could have done this problem 2 different ways, the second part. You could have found the center and then found the distance using the center and one of the endpoints. I just didn't want to have to deal with fractions. So I found the distance of the diameter and then divided by 2 since the radius is half the diameter. Okay. As always, every time, can't thank you enough for tuning in. See you later.